Okay, so on the previous couple of problems, we looked at the vertex form, where we could find out the x and y coordinates of the vertex and the axis of symmetry just by looking at it. But now we're going to look at something that's a little more common. We're going to call it the standard form. Now, I'm going to have us do this process one time and then probably never again. So this is the vertex form. F of x equals a times x minus h squared plus k. And I'm asking us to expand this. What expand means just do all the multiplication. Do all the multiplication and combine like terms as needed. So, taking a look at this, we've got a times x minus h squared plus k. This x minus h, we're going to have to expand out. So we're going to say a times x minus h squared, sidebar. Remember, x minus h squared is not the same as x squared plus h squared. We don't just distribute that negative. Or sorry, not the negative, the exponent. What we end up doing is doing x minus h times itself. When something is being squared, we're multiplying it by itself. And I would strongly encourage you to write that out if you're doing a process like this. So now we have a times x minus h times x minus h, and then plus k in the end. So let's go through and actually do that multiplication here. So this guy here, we're going to go through and FOIL. I'm going to use the word distribute because FOIL is a little too specific. FOIL works here, but distribute is going to be the key thing. So we're going to take each member of x minus h, this first group, and distribute it to the other x minus h. So we're going to do x times x. Let me write out the a out here first. X times x is going to be x squared. X times negative h is negative h. Or sorry, negative hx. And then this negative h times x is going to be also negative hx. And then we have negative h times negative h, which gives us positive h squared. Now we still have that plus k hanging out on the end. Now we've got a times x minus, well, let's clean up that group. We've got some common terms here in the x minus h, or sorry, hx's. So we have a still multiplied by this whole group. This whole group we've got x squared minus 2hx plus, I made a typo here, I'm sorry. It was supposed to be squared in parentheses. My apologies. So we have x squared minus 2hx plus h squared, and then still plus k in the end. Now a is being multiplied by the whole group, so we're going to take a and distribute it to each member of that group. So we have ax squared minus a times 2hx is going to be 2ahx. And then a times h squared, we're going to have ah squared, and then we're going to have plus k. Now we've combined all the terms we can. We have all the terms with the same variables. Folks, I got to be honest, this doesn't look super neat. There's a lot going on here. Ax squared minus 2ahx plus ah squared plus k. What we're going to do is we're going to simplify it down, and we're going to use a different format. We're going to say f of x equals, and you probably have seen this format before, ax squared plus bx plus c. Now I want to kind of like identify these pieces where they are going to match up. So, sorry, my stylus is being fussy. So the ax squared is going to match up, that's no problem. The negative 2ahx is going to match up with bx. And then the c is going to match up with everything on the end here that doesn't have a variable. We're going to talk more about this in the next page. Okay, so just repeating. The a matches up with the a. The b is going to replace that negative 2ah. We'll deal with more of that in a second. And then ah squared plus k is c. That's a lot going on there. Let's take it piece by piece. So focusing on the a, again, the a doesn't change. It's still the same a. We're not doing a times h or a times whatever. It's just a. So it still determines if it's a reflection or a stretch or compression. Remember, it's a reflection if your a value is less than 0. It's a reflection over the x-axis. So you'd be flipping it upside down. Sorry, let me move my picture a second so you can actually see what I'm writing. There we go. So it's a reflection over the x-axis if your a value is less than 0. It's a stretch if the absolute value of a is greater than 1, and it's a compression if your absolute value is between 0 and 1. So big numbers like 4 or negative 12, those would all be stretches. Or if you're multiplying if you're multiplying a, and then it's like 1/2 or 2/3 or -5/8 or something like that, that would be a compression. Now the b value is going to be a little bit more detail. So let's talk about that. So it says because b is equal to -2ah, or the other way around, we can solve for h, the axis of symmetry, to find how it's related to b. So our axis of symmetry, we said, was x equals h. Now right now, we want to get that into a form where we don't have h, we just have, well, whatever's left. So we have -2ah equals b. Let's solve that for h. Well, in order to do that, let's divide both sides by -2a. So we're going to say h equals b over -2a. Now another way we can write that is, since the numerator is positive and the denominator is negative, we can just put the negative out front. We can say -b over 2a. It really doesn't make a difference where the negative goes. In fact, sometimes I write it as -b over 2a. Doesn't make a difference. And now I also probably should emphasize, you don't always want to think about it as negative. You want to think about it as the opposite, because sometimes it already starts off negative, and then you have to take the opposite of it. We'll get to that in a second. So the axis of symmetry is going to be x equals -b over 2a, or the opposite of b over 2a. So that's how it's related to our axis of symmetry. The last thing, the c value. Let me move my image again so we can see what I'm talking about. Sorry, dad joke there. So we're asked to calculate f of 0. So we don't have a, b, or c. That's okay. So if we do f of 0, it'd be a times 0 squared plus b times 0 plus c. So we'd end up with, let's see, that's 0, that's 0. We end up with f of 0 equals c. Well, what does that represent? That is our y-intercept. So that's our y-intercept. Whenever x is equal to 0, that's really saying, where is it touching my y-axis? So in summary, let's put these things together a little bit. For the equation f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0, because if a is equal to 0, then it's not a quadratic anymore. Couple things. The first thing is the parabola opens upward if a is greater than 0 and downward if a is less than 0. It's kind of dealing with those reflections. So if it's got a positive a value, it's a parabola opening up. If it's got a negative a value, it's going to be a parabola that gets reflected over the x-axis and opens down. The axis of symmetry, we talked about that a minute ago, is the line x equals -b over 2a. The vertex, there's a lot going on there. The vertex, let me shift my image so you can see a little bit better. The vertex, it says it's got the coordinates -b over 2a and f of -b over 2a. That looks like a lot of work. Well, let's break it down because it won't be as much work. So -b over 2a, or the opposite of b over 2a, that you already have. That's from your axis of symmetry. You'll notice it's the exact same thing as we had here. The f of -b over 2a looks like a lot of work because then it feels like you got to figure out something and then you got to plug it in. Well, we already know what -b over 2a is, and we're just going to say is plug in the x value. We know the x value from our axis of symmetry. Now we just got to plug it into the function to find the y coordinate. Last part, the y-intercept is c. So pretty straightforward on that.